For a long time, I swore I would never be an engineer because I didn't really understand what they did. I was like, oh, that's boring, I don't want to do that. But after a while, finally, I paid attention to what all the engineering people were telling me, and I was like, you know what? That's really cool. Hi, I'm Michalka, a senior agricultural engineer from Ennis, Texas. I'm here at A&M outside of the Hopgood building, which is where we have most of our agricultural engineering labs. We have labs that do water quality testing, we have machine shops, and we also have the lab I work in, which is the new bioenergy testing and analysis lab, or BETA for short. Okay, now that you know a little bit about me, let's go on in and take a look. Agricultural engineering isn't a field that you hear too much about, but it's actually, I think it's extremely interesting. Agricultural engineers basically work with engineering the essentials of life, which means food, air, water, clothing, anything that processes it or produces it. Agricultural engineers take care of it. We've got ag engineers at Frito-Lay developing your chips. We've got ag engineers out at Bluebell making ice cream. A lot of them work with farm equipment, go to John Deere, work with designing new equipment there. Yeah, ag engineering is wonderful because it's a balance between biology and the physics and mechanics that is more traditional engineering. I'm working on a research project to create ethanol from wood molasses. Ethanol, if you've been paying attention to the news lately, is an alcohol that can be used as a replacement for gasoline. It's a clean burning fuel. You can mix it with gasoline, put it in your car, and it works really well. The wood molasses that we're working with is a lot like the molasses you're used to. It looks like it smells like it, but it's actually made from boiling wood chips down and getting the sugars out of those. It's a waste product from the lumber industry, and so they've got tons and tons of the stuff that they don't know how to get rid of, and they want to find out if they can make ethanol out of it. I got interested in this project because you're not only producing a valuable commodity, which is the ethanol, but you're finding a new use for a waste product, which otherwise is just hard to get rid of. And that's a big problem in a lot of today's industries, is they have these waste streams that they would put into landfills or they're dangerous to dispose of, and a lot of times you can make valuable products out of that. And this is a prime example where you take the wood ethanol, or you take the wood molasses, which isn't very useful, and you turn it into something that has great value to society. This is where we start our experiment process. Ethanol is produced by microbes, many different types of microbes, that eat up sugars or starches that are available in a substrate and produce ethanol as a waste. We're working with 3 different microbes, and it's 2 yeasts and a bacteria. If you've ever made bread, you know that at one point you have to add yeast to the mixture, and as that's working, the yeast produce both gas and ethanol. The bread rises, and when you bake the bread, the alcohol goes away, and you're left with a nice big poof of bread. This is the incubator where we keep our microbes. Here is what they look like when they're growing. You can see they're not very pleasant looking, but this is what we like to see. Once we get our microbes, we put it into a fermentation, and the small flasks are the ones that have the wood molasses in it, and we add microbes to the wood molasses, and they sit there for about 5 days, and each day we take samples to run ethanol and sugar tests. Once we've taken the samples, we have to find out how much ethanol is in it each day and what sugars are being consumed, because there's all kinds of different sugars inside of it, and some microbes prefer some sugars over others, and we want to make sure that they're all being consumed. This is an HPLC, a high-performance liquid chromatography system, and if you watch CSI, this is the type of equipment they use for some of their analysis, and when we run samples through here, it'll tell us what sugars are there and in what quantities. Another step in the sample testing process is to determine the amount of ethanol in the fermentation at each day of the test. This is our gas chromatograph, which is similar to the liquid chromatograph from earlier, but it actually combusts the materials and analyzes the gas phase. Works much better for ethanol than for sugars because ethanol is volatile, it burns much more easily. What we do is we take up our sample in the syringe and we inject it to this port right here. And then as it runs through the machine, it will eventually give us a graph on the computer that shows peaks to give us how much ethanol is contained in that. It's also something that you might see on CSI, but I would like to point out it takes a lot longer than they let you know on the show. At least half an hour for a sample instead of the just easy print off that they get. Once we're finished with the fermentation, we take out our flasks and we have to extract the ethanol because inside of a fermentation it never goes above 10 to 12%, otherwise it would kill the microbes. But we want it in as close to 100% as we can get. So the way we do that is we have a distillation set up here. It's just small bench warm. The flasks that you saw inside the incubator will go up here and it'll be set to a temperature above the boiling point of ethanol but below the boiling point of water because they have different boiling points. The ethanol will boil and the vapor will come into this little apparatus here. This is our condenser. We have cold water flowing through here that condenses the ethanol vapor as it runs down, and then we have liquid ethanol down here. It also helps to determine the amount of ethanol because once we've boiled this for long enough, we have all the ethanol in here and we can do the math and determine the percentage that we have to begin with. Okay, so after all of the testing and the analysis and the fermentation, we saw our distillation. We end up with pure ethanol, which can be used as fuel. That's our main product. The main goal of the research project is to eventually scale this up to a industrial-sized process where the lumber plants can take their waste right out of the plant, plug it into a large fermentation, large distillation, and come out with hundreds of gallons of ethanol to sell, to use. That's our main goal. The U.S. Department of Energy has a new program running called 25 by 25, where they hope to be running a quarter of the U.S.'s energy supply off of renewable fuels. That's solar, wind, ethanol, and biodiesel by 2025. The reason we want to do that is because, first of all, eventually we're going to be running out of oil. Oil is a non-renewable resource, and we're starting to run to the point where it gets harder and harder to find, and then eventually it'll all be gone. If we don't have some other methods of gaining energy by then, we're going to be in major trouble. And that's where my research comes in, is that in order to be running 25% of our energy off of these sources, we're going to need to be able to create a lot of it. And this is going to be, hopefully, a way to produce mass quantities of ethanol. If you're thinking about coming to college, I would tell you to get involved. If your school has science clubs, engineering clubs, anything in that line, get involved, stay involved. And although this is kind of far ahead for you guys, start early. Research your colleges, know where you want to go, apply as soon as you can. That helps out a lot. And once you're at college, take advantage of all the opportunities that are available. If you come to A&M particularly, there's mind-boggling amounts of things to do. I've been to Italy, I've been to Mexico, I get to go tour manufacturing facilities all over Texas. There's any number of opportunities for you here at A&M, and the way to get the most out of your experience here is to take part in as many